Hello and welcome back to another episode of Math with Sohn. Today we're going to be learning about how to determine if a triangle is going to be right, acute, or obtuse just based off of the side lengths. Okay, so if we take our Pythagorean theorem, a squared plus b squared equals c squared, if it is equal to c squared, then we would know that it is, in fact, a right triangle. So if it's equal, it's a right triangle. But what about if it was a squared plus b squared is greater than c squared? What if that was way bigger? So in that case, what would happen would be that the a and the b would be bigger than the c in relationship as before. So it'd kind of look like this, where the a and the b are just bigger, and that makes what we would call an acute triangle. Now, if the c is really big, that would mean that we would have a squared plus b squared is smaller than c squared, meaning the c is too big. If the c is too big, then your a and your b are little guys, but your c is really big, and you have an obtuse triangle. Okay? So this is a really easy process, provided you know what the Pythagorean theorem is, and we're going to do a few problems to practice it. So let's say that we had side lengths of 3, 7, and 9. We just need to determine if this is an acute triangle, an obtuse triangle, or a right triangle. So your a and your b are going to be the smallest sides. That will never change. 3 squared plus 7 squared. We need to compare it to 9 squared. It's probably not going to be equal to it, but it could be. We got 9 plus 49 compared to 81. If we add these two together, we get 58. And 58 is smaller than 81. If the c is the bigger part, if this is bigger, then we have an obtuse triangle. All right. What if we had, let's say, 4 and then 11 and then 16? Now, just to be like a review, you have to make sure that these are even possible to be triangles. So let's say that you had 4, 11, and 16. Always remember that the two shorter sides, these guys, have to add to equal more than the biggest side. Well, what happens if we add 4 and 11 together? You get 15. 15 is not more than 16. This is not even a triangle. So always double check your teacher maybe. Maybe they're giving you a bogus problem to begin with. Make sure the two shorter sides are always going to be more than the longest side, and it can't be equal to it. It has to be more than that longest side. This is not even a triangle. We can't even confirm it's a right triangle or acute if it's not even possible. All right, next one. Let's say we have 4 and then 8, and let's make sure this is a triangle, and let's go with 10. So 4 and 8 would be 4 squared plus 8 squared compared to 10 squared. That would be 16 and 64 compared to 100. If we add these together, we get 80. Well, 80 is again smaller than 100, so this is again an obtuse triangle. Let's see if we can get some acute and right triangles in here. What if we had 6 and 8 and 10? If we did 6 squared plus 8 squared compared to 10 squared, first off, 6 and 8 add to more than 10. It is a triangle. You get 36 and 64 compared to 100. We don't know what it is yet. We get 100. Well, 100 equals 100. If that is the case, then it is a right triangle. It worked. The Pythagorean theorem was true. It's a right triangle. The only time the Pythagorean theorem is true is when it is a right triangle. All right, one more. Let's say we had an 8, a 9, and a 10. So real simple, 8, 9, 10. A, B, C, 8 squared, 9 squared. C has always got to be the biggest one, which apparently I like 10. 64, 81 compared to 100. Add the 64 and 81 together, we're going to get 155. Well, 155 is way bigger than 100, and that means that this is an acute triangle because the C is small. If the C is small, that means that part that would need to connect the A and B together would be smaller, and it would be acute. All right? So that was a real quick one for you. Until next time, stay positive, and I will see everybody later. Bye.